So today we're going to learn about fundamentals of factoring more simplistic expressions. They're linear expressions because they're not to the second power. When we talk about factoring, so here I have 3 times 2y plus 6. This means I'm going to do 3 times 2x actually, plus 3 times 6. So this becomes 6x plus 18. This is kind of the opposite of factoring, is using the distributive property. So when we factor these expressions, we're basically looking for what we would use to simplify a fraction. So we're simplifying this, we're taking a piece out. So we're going to look for the greatest common factor between this coefficient and this constant. Sorry about the AC. So here I'm actually going to factor out a -2. So this is going to have a -2 on the outside, an n on the inside, and a +7. So I picked a -2 just to show you guys this could be factored 2 ways. It could also be 2 and a -n minus 7. Both of those are going to go back to that original expression. And we'll look at some of these using graspable math after I do these examples. Again, here you could make a list of the factors. I can kind of see that both of these I can factor out a -7. And then I'm going to have the k. And then negative 56 divided by -7, it ends up being -8. Another thing that you need to understand is that this is k and a -8. So you're doing -7 multiplied by -8 for that term. Here, I know I can factor out a 3 out of both the 3 and the 9. But the nifty thing here is I can also factor out an x out of each of these terms. So I can actually factor out 3x, and then this is just going to be a 1 left over plus a 3y. I do want to put that 1 there because 3x times 1 is where that 3x comes back into play. Again, here I do have the possibility of factoring out a positive or a negative. I'm going to factor out a -5, which means that this is going to be 20 divided by -5 gives me -4n, and then -15 divided by -5 gives me a +3. If it ends up as a positive, you kind of like plop it down on the page and it says +3. You could have factored out a +5, and then this would just be 4n minus 3. You just have to remember those integer rules that we've learned previously. Now this one, can 16 be divided by 3 evenly? The answer to that is no. There's really nothing that they have in common. But I could actually end up factoring out a negative if I wanted to. But generally speaking, we'll say cannot be factored for this question, but I can really factor out a negative, and this is going to stay 3n and then minus 16. The reason I brought up this example is because I'm going to end up actually distributing this negative sign. So -1 times -3 is +3. -1 times -16 is +16. And you guys might be asking why I'm saying -1. Well, what's hanging out with this negative sign? It's a little 1 that's chilling and hanging out with it. Okay, so here, both of these can be factored by 8. So I have 5n because 40 divided by 8 is 5, and then minus 7 because 56 divided by 8 is 7. You could have also factored out a -8. And if you factor out a -8, it's going to be a -5n, but a +7. The -8 times -5 is the +40. -8 times +7 is the -56. So we can check that. This one is another one that we would say cannot be factored. Normally, I'm just going to again show you can factor out a negative. If you're wanting to factor out a negative, but the best answer for this one is cannot be factored. I'm going to come back with two examples of using this in conjunction with perimeter and in conjunction with area. So when I come back, those are going to be two examples on the So I'm back with a perimeter question and an area question. So it says the perimeter of a regular hexagon is 12s minus 24. So some things you need to know to be able to do this question is you have to know what it means to be a regular hexagon. So think about that just for a second, and then I'll kind of define it for you. Well, first off, a hexagon has how many sides? It has 6 sides. And a regular hexagon means all the sides are exactly the same. Regular means that all the sides and angles are equivalent. So here, basically what I'm going to do to get the expression that represents each side is I'm going to take 12s and divide by 6. And I'm going to take negative 24 and divide by 6, because that's the number of sides that are in that hexagon. So here, 12s divided by 6 is 2s, and 24 divided by 6, or negative 24 divided by 6, is 4. So each side of that hexagon is 2s minus 4. Now you could, again, go back and redistribute so that you make sure you get the 12s minus 24, and again, you could use graspable math for that. So the area of a rectangle is 6xy plus 12. What are two expressions that could represent the sides? So we know that area is found by doing length times width. So what here, we're trying to find something times another expression that once we distribute goes back to being this original expression. So here, again, we're going to look for that greatest common factor. The greatest common factor between 6 and 12 is 6. So we know we're going to take both 6xy and divide both of those by 6. Some of you guys might be shouting at the screen that can we also factor out a y? So we can also factor out a y. So we can really be dividing by 6y. Well, 6 divided by 6 is 1. So what we factored out now is the 6y. That's what's going to be on the outside of the parentheses. And then we have x. You can put 1x if you want. And then plus 2. So now the sides of this rectangle, side 1 could equal 6y, and side 2 could equal x plus 2, because that's going to go back and give us that area. Now, if you didn't factor out the y as well, this would be xy here, and this would also need to be 2y. So now my sides could be 6 and xy plus 2y. Those could be my sides. But whatever is outside the parentheses can represent one of the sides, and whatever is inside the parentheses represents the other side of the rectangle. So if I'm going to draw this out using my answers, I could say this is 6y, and then this is x plus 2. And then again, this is 6y, and this is x plus 2. So then you can find the perimeter of this rectangle is 12y plus 2x plus 4. I'm just collecting the like terms to find the perimeter. So perimeter equals that in this case. So I hope that helped. So here you see 3 of the examples that we did in the video, and I'm just going to check them really quick using graspable math. So whenever you're trying to check, you need to kind of make sure you're moving the piece that you want to move. So here I'm moving the 7, and notice that it factors the 7 out, and it comes up with negative k plus 8. Just please note that you could also factor out this negative, and then it's going to end up being k minus 8. If you are uncomfortable with the 7 being at the end, that is another way to write distributive property. You can move it to the beginning. But for some reason, it's not letting me remove the negative symbol. Here's another one. We did 3x plus 9yx. So if I bring this term over, and I'm just bringing 3 right now, it's going to just factor out the 3. And then I can also bring over the x, and it's going to factor out the x. Again, if you are not comfortable with this being at the end, you can try to carefully move the pieces back over here to the front. Notice it does put the dot that indicates multiplication. Another cool thing is you can go back in and you can distribute everything back into those parentheses to see if it goes back to the original function. This one was about the regular hexagon. So we ended up with 2s minus 4 represents each of the 6 sides. So we can again bring this in here, and it shows us, yes, this does go back to 12s minus 24. And the reason that we only factored out a 6 here is because there were only 6 sides. Now this factor completely would factor to s minus 2, but that's not what we wanted in this particular case because we knew that there were only 6 sides. But again, that's a cool way that you can use Craftable to check your answers for the factoring section. And know that factoring will get more complicated in the future whenever this is x to a higher power.